Welcome to the AI, the Future of Us, a podcast-style video series that explores the ways AI is shaping our future and how we can prepare for the changes that lie ahead. I am your host, Fırat Sakiner, and today we are joined by Søren Peterson, who is a Data and ML specialist here at Google Cloud. Thank you for being here today, Søren. I know that we both started our journeys in academia with our PhDs, but in different ways, and eventually ended up being data and AI professionals, and we have been doing this for a while. But with that, can you also tell to the audience here a bit about your background and expertise in the field of AI?
Sure. So thank you for the invitation, Tina. I started out as a data scientist, business analyst at Google. And during that time, I already worked on machine learning specific projects, mostly focused on natural language processing like text classification. After that, I moved to Google Cloud, and there I started to work as a machine learning specialist. And in this role, I advise companies on AI and large-scale data and AI infrastructure.
How did you become interested in AI, though? And what do you find the most fascinating about AI?
Well, I was always fascinated that data, traditional statistics, and then later AI allows us to see a different representation of the world. So take embeddings, for example. With machine learning, we are able to represent unstructured data, such as text, numerically in a lower dimensional space. And this allows us, for example, to understand if one sentence is similar to another sentence. And I always found this interesting to have like a different view of the world.
Yeah, it's interesting, right, that how the traditional statistics really, still works very close with AI and everything that we do. And could you share some of the, AI developments that, you witnessed during your career and the things that really, stuck with you as well?
Sure. From a research point of view, I think the introduction of the transformer architecture in 2017 with the seminal paper "Attention is All You Need" was a turning point, and it basically paved all the way for large language models as we know them today. The second thing is that the increasing relevance of machine learning operations, or MLOps as we call it. When I started my current role approximately 5 years ago, a large part of companies were still like tinkering with machine learning. They were doing POCs and they were trying out what machine learning had to offer. Nevertheless, we did not see many machine learning projects in production during that time. This has changed tremendously over the years, and the productionization of machine learning has become way more prominent. Like frameworks like Kubernetes or Configure pipelines rose in prominence, and some of the discussions have shifted away from like, how do I train a model, which is still important, to more, or like to different kind of discussions, like how do I build a scalable model registry, or how do I automate my test processes? And the third thing that I have also has changed is that the shift from creating your own models from scratch towards transfer learning for traditional architectures, and nowadays using fine-tuning and prompt tuning for large models and large language models in particular.
That's interesting, right? And how much we have come through, in particular from, attention is all you need, that everyone is talking around the attention and the context of, the language in a sense. I remember the days that I used to work at the, National Center for Text Mining when I was in academia 15 years ago, and we didn't have any of that. It was really hard, even in academia, to get this running. It's interesting, that, we are observing that as well. But one of the other things that I always seen throughout my career is that there's always this gap between data and the machine learning, whether you are a data analytics professional or a data engineer, or whether you are a machine learning engineer or a data scientist. And according to you, what are the main overlaps that you see for traditionally two separate disciplines that we see in the industry a lot? We operate a little bit differently, but that's what we see outside a lot as well. How do you think that how it overlaps?
Sure. So I think the first one and the most obvious one is that both build on robust data, like both need to have like a robust data ecosystem. And for most of the tasks, the data that you have, the quality of the data and its accessibility define the success of every downstream processes that you are building upon. And it doesn't matter if like you're building or if you're retraining a 1 billion parameter large language model, or if you try to generate statistical inference using a logistic regression, data quality and its control are crucial. The second part I see is that, and this is my personal observation, is that engineering best practices and machine learning best practices have become more relevant for traditional data analytics. And this means like using version control, writing tests. This might have like several reasons, but one of the reasons might be that in particular in smaller companies, data analysts or analysts in general need to wear several hats. And one of these hats might be or is, for example, the head of the data engineering. And the third point is that I believe that Python has become the de facto standard in data analytics, but also machine learning. And having a common language between these different fields, between data analytics, between machine learning, and data engineering really has helped that those three fields have grown together more closely.
Yes, it's interesting, right? And we are also seeing that with the, with the LLMs and the generative AI, we are seeing more and more they're coming together. So we are seeing more overlap, and the two distinct environments are coming together more and more because it is allowing and it is uplifting the users as well. And that's some of the things that I'll come back and ask you in a minute. But before I get there, the challenges that we see with the separation of these two organizations, it's also challenging to get into production systems, right? And it is taken that we are using all of this, but it is a different matter to bring it into production. First, we need to sort out as you said, the data and the data ecosystem. We need to have all the data governance practice in place as well. So with that, how do you see the DataOPS and MLOps with LLMs in mind evolving within the next few years?
Sure. So the overall answer is that data and MLOps will become more relevant. As we addressed it already in the previous question, like successful data and machine learning systems rest on like analytics and machine learning systems do rest on a solid data ecosystem. To be a little bit more specific, quite often, like when we work with LLMs, they seem to be like magical, so they work without data. You do not need to train them because they come pre-trained and then they can do something. Nevertheless, for a significant part of use cases, language models and large models or large language models need to be aligned with the user's intent. And the term of alignment will come, like we will touch upon this term, I guess, in the next questions. But in order to align those models with the user's intent, large language models and language models and large models need to be tuned. And to do so, you need to have like good data quality. So data quality is pivotal. The second thing is that a large part of machine learning operation deals with model performance and explainability. So you want to know, is the model doing what it should do? And then you also want to know, like, why is the model, what the model is doing? So how does it reach its conclusions? And LLMs have the tendency to be a little bit more opaque compared to traditional machine learning models. And this is why machine learning operations and MLOps is so important, because you have this explainability part and you also have this model performance part. And this is where you need to put an extra special emphasis when you talk about large language models. And the third part is that we always need to envision machine learning models being part of a larger technical landscape, because quite often when we discuss machine learning and we just focus on the machine learning model, but those models are always embedded in a larger technical landscape. And in this case, we talk about machine learning systems. And if we assume now that the data complexity is increasing, that we have to deal with more data in the future, but that also the opaqueness of the model, or the complexity of the models is increasing, what we will see then is that, and this is the direct result of those two trends, that data operations, but also machine learning operations will become way more relevant in the future.
I totally agree with you, and I think we'll be seeing more and more that the data governance and the ML governance is coming together, because you're your ML is really as good as your data at the end of the day, right? So the Harvard Business Review article still sticks with me that the headline was your AI applications will be as good as your data analytics applications, and that's really correct. And we have been doing, machine learning for a long time. There are many applications in many industries that are used on a daily basis as well. However, with LLMs, we are now making this more mainstream, given the way that they work, they really bridge the gap, And how do you see these challenges, on applying and using generative AI in particular?
So the challenges when using generative AI. So first and foremost, I guess the biggest challenge is that we need to take, as I said before, we need to take a step back and think about, when we think about large language models and generative AI, as being part of a larger machine learning system. So thinking from data extraction to data processing, to the model training, to the model serving. And generative AI or large language models have definitely added some additional challenges in certain areas. For example, in terms of explainability, as we have discussed before, but also in terms of training. But I guess the core challenge has remained the same in terms of machine learning, because what we want to do is we want to build, first of all, a robust data ecosystem first, and then we want to build a robust end-to-end machine learning systems. And what we have discussed before is one of the key challenges with large language models is that they are opaque. So we need to put, again, specific, special emphasis on explainability and performance, which also includes fairness. And second, there's also a technical or more engineering perspective, because as the name says, the models are pretty large. So we need to think about how can we train them efficiently and effectively, and how can we not just train them, but also how can we serve them? How can we make the serving fast? How we can make the serving cheap? Those are the things that we need to think about from a more engineering ops perspective, so to say.
Yes, I agree, and there's lots of discussion around that within the AI and ML ecosystem. I think it is really a thing, particularly how you use the prompt, whether you are using specific corpus, for example, for the model that you are training, whether you are getting a specific outcome or you are looking to get specific outcomes. It is really it is kind of like multi-objective optimization problem. How much effort that you put in and how much value that you get out from the business side of things, really. But what are the examples that, you are seeing with Gen AI use in the, industry, and what are the things that you have been seeing?
Of course. So I'm working a lot in the retail industry. And so far, what we can say is we are still exploring all the different possibilities, because there are so many things that you can basically do with large language models. So to start a little bit more high level and to think about more abstract about the core capabilities of what those models can do, there are three main capabilities, I would say. Of course, there are more, but for this discussion, let's think about three things that those models can do very well. One thing is search. You can use those models, for example, to search code, to search documents. And this is a huge huge thing, because in a lot of companies, there's a lot of information available, but this kind of information is not accessible. And helping companies, and internally as well as externally, accessing this information with large language models is very important. And it's a great use case. The second thing is everything that is related to content creation. So you can think about using large language models for creating code descriptions. You can use it for creating images. You can use it for creating text, and you can also use it for creating metadata. So this is also super interesting. A quick example, maybe I have a bottle here. So if you're searching internally for a bottle, your current metadata maybe just says this is a bottle. This is a bottle of water, or this is a glass bottle. And when I'm looking now in my system, and I'm typing in the following, I want to have a healthy drink, then it would not find this, because it doesn't have the metadata. It doesn't know that this is healthy. But if I ask a large language model, for example, what is a healthy drink, it's quite likely that it will say well, water is a healthy drink. So what I can do is basically, by combining those capabilities, this general knowledge of the world, with, for example, the metadata that I have, I can do this. I can like do a search, and then, for example, customers can search my catalog, or internally I can search something and say like, well, give me a healthy drink. And it gives me like, well, maybe you try it, and maybe you try water. So this is the second thing, the second part. And then the third part, of course, is everything that is conversational. So classical chatbot. And this is the third big use case, or the area where we see a lot of potential with large models and large language models.
And it's interesting, right? Because the search has been using LLMs in Google side of things. When you go to Google search for, for some time, as you're typing, it would give you that context, But I also want to see, specifically for data analytics, what are the use cases that you are seeing? And any specific things from the data analytics side of things?
Yes, of course. So for data analytics, I think there will be a great democratization of analytics, and it will be way easier to interact with data. So let's assume the following. You are working at a retailer, and you want to do the following. You need to write some SQL code, or let's start differently. You want to have some information. So you would like to have the information. I want to have the sales numbers for product X for the last 2 years for country Y. So what you can do is you can go to your database, you can write some SQL code, and then you can write the code, obviously, and then you get the answer. But maybe you're not so familiar with SQL. So what you can do instead is you can use a large language model, and you can ask the model, what I want to have is like, please provide me the sales numbers for product X for the last 2 years for country Y. And then the model will translate, so to say, your ask into SQL code, and then you might give it access to your database, and then we can return to you the results. So this is the first thing, democratization. The second thing is also, which is also relevant, is that you can make data more accessible. So assume the following use case: you're an analyst, and you get the request like, we want to understand like how satisfied are customers with one of our products. So what you would normally do is like, maybe you have like customer ratings. So you would run analysis on customer ratings. But what if you have a lot of text? So you have a lot of reviews, and you would like to deep dive into those reviews. And like, think about like 10 years ago, or like 5 years ago even, it was not so easy to handle this kind of unstructured data. So you needed to have like knowledge about like natural language processing. So it's tricky. It's not super easy. But what you can do today, for example, is you can ask a large language model, look, here's a review. This is the review text. Please read this review text and give me an answer if this review is a positive review, a neutral review, or if it's a non-positive review. And by doing so, you can leverage, for example, unstructured data, in this case text data, very easily. And this is the second big trend, or the second big benefit that I see, that you can make your data more accessible, and that you can leverage different kinds of data, in particular unstructured data, something which was not so easy a few years ago.
And that's interesting, right? Where we are, getting really, so we discussed this, that the democratization is really key. It is an overloaded word, but, I'm a programmer by trade, and I program so many things in life. But I find myself, I go to Barden, I ask for, the code snippets and stuff before I get access. I do anything now, right? So it gives me really, code that works as well. It is really fascinating. But also from the data analytics point of view, it is interesting to see what is it coming, whether, I can use directly from things like BigQuery, LLMs by calling Vertex AI, LLMs, and I can look into sentiment or some unstructured text and stuff as well. And with that, right, what advice would you give to individuals and businesses looking to prepare for the future, because where AI plays even more significant role in data analytics, as we discussed, right? It is going to become more and more upfront, and everyone will be, it is touching everyone's journey in a sense, in data journey.
Yes, that's a very good question. So my answer is like a non-technical, non-AI answer. And so the first thing I think you should do is like strengthen the domain-specific knowledge. And this is becoming super important, that you know a lot about your domain, because AI and analytics are tools helping you to answer a question, but it's up to you to come up with a good question. So unsurprisingly, the quality of the questions that you ask strongly correlate with the quality of your domain knowledge. So the very important thing is that you have some domain knowledge. For example, if you're an analyst, get some domain knowledge, and if you're working in retail, get really domain knowledge into forecasting. How does the forecasting process look like? What does it mean to create a good forecast? And then think about okay, how can I leverage AI in order to do better forecasting, for example? So this is the first. And the second thing is that when we think about AI, we often think about AI in an incremental way. So we have a process or we have something and then just put AI on top. But in particular, when you are trying to achieve some non-incremental change or some radical change with processes, you might think about not just treating AI and also for analytics as an add-on, but that you really start to rethinking a business process from scratch and really start, how can we really rethink the whole process and the whole thing, starting with AI and not just having the process as it is yet and just adding AI on top.
Yes, and it's interesting, right? That I agree with you that you still need that knowledge. Also, I want to, in order to get the value out of it, you should be able to understand the feedback that you get from the machine as well. But also, your creativity is going to play a significant role, in my opinion, here, right? Because it is going to make you more creative. You'll be able to, get away from the repetitive tasks by using, LLMs in your day-to-day work, and it will allow you to be more creative. It will also give you more tool set to, display and get your creativity out as well. And that also requires the knowledge, as you say. And as we look ahead, and this is my last question to you, Søren, as we look ahead to the future of AI, what do you believe are the most critical areas of research and development that still need to be, addressed as well?
Yes. So I guess the biggest topic is alignment. We heard it before, and alignment basically says what alignment means is that a model behaves in accordance with what a human wants, and there are a lot of things that you need to do in order to create this kind of alignment. And one thing, so there are basically three things, but the first thing is that customization and fine-tuning, because just having a large language model is often not enough. So the model needs to be tuned or fine-tuned according on your domain-specific or use case-specific or on a particular use case. So there's a lot of research right now on how to actually do the customization the best way, using your own data. I mean, you might have heard terms like prompt tuning, fine-tuning, full fine-tuning, etc. And there's a lot of research going on right now. Okay, how do I actually customize or fine-tune my model so that I can achieve the results that I want to achieve? The second thing is that explainability, and we have stressed this before. We want to know why does a model make a certain decision, because only when we know why a model is doing, why a model is doing a certain decision, we can then analyze. Okay, was this a good decision or was this a bad decision? And finally, we have engineering challenges, because as the name suggests, large language models are super large and they have very specific requirements for training and serving. And we need to think about how can we serve those models and how can we train those models very, very efficiently. And those are three major points, I guess, that all are all sub points of this general topic of alignment. How to make the models useful and how to make them behave the way that the user wants them to behave. And this is where I see a lot of research going on in the future.
Yes, and I agree, and we are seeing a lot of work happening in this area. It is interesting, right? Because Google has been doing this for a long time. We learn a lot. We applied all of this in our, systems and applications. We publish over, 1,000 papers annually, right? And it enables us to collaborate and share ideas as well as learn from the broader scientific community as well. So, and we'll I think we'll see more of that. It will allow us to, be the leaders on this as well. Thank you for joining us today, Søren. It has been really insightful to hear your thoughts with your experiences and how on the impact and effective use of AI. It's great to understand the, specific parts around the data analytics as well. We look forward to seeing how AI will continue to shape the world around us, and hope our viewers will be inspired to embrace its potential and the opportunities. We have a lot more, video casts coming up as well. And look at the, playlist. We already published a few, and we'll be releasing more interesting discussions like we have done with Søren today. Thank you very much.
Thank you for having me.